This conference will now be recorded.
So right now I have created a project called interface project. In this interface project, okay, right now I'll create a simple class called as a fan or projector, right? I created a simple class called as projector. The basic behavior of projector is to display public void display. So I write a logic for this, right? Display the content or project the content, okay? So this is the projector. This is the projector display. There's a method called display. This method is ideally, this is called as a service because it is meant to be called by others, right? So now I write another class called as you, right? You want to use the projector. Or let's say you want to teach someone, right? Or you want to watch a movie. This is your method called watch the movie. For you to watch the movie, what do you need? You need a projector now, okay? Let's say you can watch the movie using projector in a better way, right? So projector P equal to new projector. So I have created the projector object and projector dot, there's a method called display, right? So if you observe these two programs carefully, observe. So there is a projector class with a method called display, and here there is another method, okay? So this method is basically consuming this service, right? So such a method which is consuming the service is called as consumer method. This is called consumer method, right? This is called service and this is consuming the service, hence this is called consumer method. Are you clear? So we have these two methods. So that logic that we write here, it's called as consumer logic. This is called consumer logic. Okay, this logic is called consumer logic. This is called service and this is called consumer. In simple, I mean, if you look into this as a program, we have seen this kind of program long back. We have written a method and we have called the method. So this is nothing but method call or method invocation, correct? Method call or method invocation. All right. We have called many methods till these days. This is called method call or method invocation. So such a method or a service which is consumed by others is called as consumer. So basically you have learned this programming long back, but for the same program, I'm giving a touch of new technical terminologies, right? I'm just naming them with good terminologies. But this program, you knew it earlier. Are you clear now? So this is the basics. Now we know what is consumer, what is the service, right? So now, what do you mean by an interface then? An interface is simple. An interface is the one which is an intermediate between a service and the consumer. It is something which is intermediate between two systems. One system is called a service, the other system is called as a consumer. Between these two, it works as an interface. The system which works, that is called interface. Okay, the entity which is intermediate between two systems, that is called as an interface. So I had given you in the last class, I had given you the example of fan. Between fan and the user, switch is an interface. Between the fan and the user, regulator is the interface, right? So that regulator is intermediate between two systems. One system is called fan, other system is called the user or the consumer, whoever going to consume that fan services, okay? Similarly, I had also given you an example of basically the CPU. CPU has a lot of services and uh, the consumer, let's say it can be you or someone, some person want to use the CPU or the computer, they use some intermediates like mouse, keyboard. So keyboard is called as an interface, mouse is called as an interface, regulator, switch, they all are called as interface. All right, I have also demonstrated that. I also demonstrated that basically, uh, hold on. I have opened this. I don't know where did it go. Yes, this is what, right? Yesterday I taught that an interface alone is useless. That is, an interface without the service is useless, correct? That is, if I give you only a mouse without the CPU is useless. If I give you a switch without the light is useless. If I give you a regulator without the fan is useless. You cannot do anything out of that. All right. So if you want to really make use of it, you need to use interface along with the services. So example, you you need, for example, regulator. If you want to use regulator, you need to have the fan. Okay, then only it make. Oh, let's become fan. Right? Regulator with fan makes sense. Regulator alone really does not make any sense. Similarly, I need a computer mouse, right? I give you a mouse, but a mouse alone is useless. Mouse with the CPU, mouse with CPU really makes sense, right? Switch with the bulb. I give you only switch without the bulb, useless. Switch with bulb really makes sense. So here, in all these situations, this portion is called as an interface, and similarly, this portion is considered as the service. Okay, so this is called interface, and this portion, all these things, is called as service, right? So here, this portion is called as service, and this portion is called as an interface. So an interface must always be associated with the service. Okay, then only it really makes sense. Otherwise, it is useless. This is what I taught you in the last class. So now moving on to the example, like take an example of this computer mouse. A mouse alone, just I am going to give you a mouse now. A mouse alone, or for example, this is a mouse, computer mouse, okay? Think that right now this mouse is not connected to any CPU, okay? Or this is not connected to the computer. So can I call this computer as the service? This is called the service, okay? Now this is not connected to the service right now, all right? I have only the mouse, which is not connected to the service. Now, think about it. I can perform some actions on this, isn't it? I can perform the action. I can click this, nothing but left click, okay? Left click or the right click, whatever you want. You can click it. You can click on this mouse. You can double click on this mouse. What else? You can right click on the mouse. You can right click on the mouse, you can double click, you can just simply click, you can double right click, you can scroll up, scroll down. So you can perform many actions. Carefully observe, you can perform many actions on this. So whenever I explain, try to visualize this, right? Imagine you have only the mouse without the computer. Any actions that you perform, there is no reactions here. Okay, any action. So all these things are only actions. Try to understand it. Okay, they all are only actions, but no reactions. Only actions, but there is no reactions. Are you clear? Why the reaction is not there? Because here only action, reaction is present in the computer. Think about it. You right click on a mouse, the work will happen on the computer. The computer start displaying the options. You double click, let's say you double click on a music player. So what is the reaction? It should start playing the music, correct? I'll repeat, when you double click on a music file, you're double clicking, that action is performed on the mouse, but the reaction works on the computer. All right. So what I'm trying to explain out of this is very simple. In this entire interface, right? This is an interface, correct? This is an interface here. I write it here. It's an interface. This is the service, okay? So this interface has only actions. Clear? Interface has only actions, but there is no reactions, only actions. But reactions are present here, okay? The reactions, so the reactions are present in the computer or in the service, isn't it? So I'll give you one more example. Imagine that you have a regulator and the fan, or switch and the bulb, okay? Switch and the bulb example. Just come back to this. First, let me give these realistic examples. Later, I'll come, programmatically, I'll explain all these things, okay? So, okay, fine. Now I have a switch here. This is going to be your switch, okay? Switch is an interface. Switch is an interface, right? Also, you have a bulb, okay? This is going to be a bulb. Oh, okay. What is this eraser? Let's say this is a bulb, okay? This is going to be the bulb. Shit, I'll write it here. Let's say this is the bulb, okay? Bulb is the one, basically bulb has the elements, the system or a mechanism. It has a system or a mechanism. It has the system or a mechanism to make the light glow. This system or a mechanism which makes the things to run is called as, technically, it is called as implementation. Never forget this word, okay? This is called implementation. I'll repeat, a mechanism or a logic which makes the system to work. That is called as the implementation. Are you all clear? What is the meaning of implementation? A mechanism which makes the system to run. So this has got the system which makes this, basically this bulb to work so that it gives the light. Okay, that is technically called as implementation. Now we have an interface and we have this implementation. Okay, now imagine that this switch is not connected to, the switch is not connected to the bulb. Are you clear? It is independent. So this is the one which gives the service. What is the service? It is going to give the light to us. That is the service. Okay, and this is an interface. What are the two things that we can perform on this interface? We can perform, basically, right? We can perform two actions. What are the two actions? I can switch on, right? I can switch on, I can switch off. I can switch on, that is one action. Another one is I can switch it off. I can switch it off, okay? So I can switch on here, also I can switch it off here. Okay, carefully observe, the moment when I switch it on or switch it off, these are all only the actions. These two are only actions. Only actions, okay? Now, since the switch is not connected to the service, right? Nothing is going to work now. You perform an action called switch on or switch off, only action, but there is no reaction. Are you clear? So that's why in this interface, only action means abstract methods. Only action means abstract method. So I have to write the method like this. Void. How do we write abstract method? Switch on. Right, I'm going to write this switch on method. Extremely important. I should terminate this with semicolon without the logic. All right, so this is how we write an abstract method. Also, we must define a keyword called abstract here. Correct now? This is what we learned it. How do we write an abstract method? By using the keyword called abstract. So what is one more abstract method? Switch it off. So one more abstract method called abstract void switch off. You can switch it off, right? So these are all the two methods now. So remember, this should end with semicolon without the logic. Such methods are called as what? Abstract methods. Okay, this abstract method is technically called as what? Action, only action without the reaction. Reaction is nothing but the logic. So it means to say, in this method, we have only the action. In this method, we have only the action, but reaction is not present here, and the reaction is going to be present in the bulb. Where is going to be the reaction? The reaction is going to be in the bulb. Pretty simple. Technically speaking, this method has got only the declaration. Observe now carefully. This has only the declaration, right? Logic or implementation for this method is going to be present here. This is the logic or implementation. Are you clear? We call it as logic or implementation. Similarly, here, this is going to be my action, nothing but abstract method. Here is going to be the reaction or the implementation. Implementation is nothing but method body. So method declaration is present in interface. Method body is present in service. Are you clear now? So now this word called implementation is important, nothing but this. Here also this word is important, nothing but this. Right? What is the technical meaning of implementation? See, technically, a mechanism and a logic which makes a system to work is called as implementation. Programmatically, it is nothing but method logic. The whole conclusion out of this discussion is that an interface must have only abstract method. It must have only abstract method. Never forget this, okay? It must have only abstract method, right? So an interface must have only abstract methods, and those abstract methods must be overridden. We must override and write the logic for these methods in the subclass, and that subclass is called as service. Technically, we call it as what? Service. Are you clear? And it works, it really works only if we connect them. Okay, only if we connect them, then only things work. Otherwise, it does not work. Right? It means to say this is what I said here in this. Right? Only interface is useless. Observe here, yesterday I explained, interface alone without the service is useless. Means you have an interface, but you don't have a subclass, it is useless. So interface plus service is really useful. So the interface with service is nothing but the interface with the subclass. Subclass is nothing but service provider here, right? So now imagine that these two are connected now. These two are connected, okay? When these two are connected, whenever you are going to perform an action here called switch on, when you perform an action called switch on, at that time, what's going to happen? So light is going to glow and it's going to give the light. This bulb is going to glow, it gives the light to everyone, correct? So this is called an implementation or the logic, okay? So that's how. So you may ask me a question, says why it is related to programming, how it is related to programming, okay? This is the extremely important concept, never forget. When I say this so much, I'm giving so much of importance, so much of emphasis, then imagine what is the depth of this concept, okay? Without this concept of interface, you cannot work with anything in Java. Are you clear? So remember this. So conclusion is this: interface must have only abstract method, and these abstract methods must be overridden in the subclass, and that subclass is essentially called as service. And once we override an abstract method, we know that in the subclass we should must write the logic. That logic is also called as what? Implementation. Okay. Now, similar to that, here if you observe, we have a concept called mouse. I explained that mouse is an interface which has only action. What do you mean by only action? Only action is nothing but abstract methods. It is not going to have the reaction, right? When we connect this mouse, once we connect this mouse with the CPU, then only it works. So you perform an action on the interface, reaction will be present in the computer. Okay, so it means to say action is nothing but abstract method. Abstract method is going to be present in your interface, and the reaction, nothing but the logic, must be present in the service. That service is nothing but subclass. We have to write or declare an abstract method in an interface, and we have to override that abstract method in the subclass. This is the funda. And here you should be careful. This interface must have only abstract methods and no concrete methods. I'll repeat, it has only abstract methods and no concrete methods. Okay, actually, in fact, from JDK newer versions, like I think from JDK 1. From JDK 1.8, the things are going to be little different, right? But let's discuss about this part in a later stage. But right now, think that an interface can have only abstract methods, and you cannot write any concrete methods. Okay, the meaning of concrete method is that a method with only the method with both declaration plus definition. Declaration plus logic is called concrete method. That cannot be present, right? You can only write abstract methods. You can only declare abstract method. Now let us understand how syntactically or programmatically to create this interface and to override the method. Okay, so many students call it as interface class. No, don't call it as interface class. It is only an interface. Are you clear? It's only an interface. Now we're going to understand in our further session. Now we're going to understand how to write the logic for this, how to programmatically create an interface, and how to override these methods. So I hope you understood until now.
This conference will now be recorded.
Now let's understand how to practically create an interface. Okay, just observe. Interface is created like this. Okay, earlier when we used to create a class, we used to use this option called class. Now you use an option called interface. Just click on next, right? So for example, you right click on your project. When you right click on your project and new, you're going to get an option called interface. Select an interface. Let's say mouse is going to be an interface. Okay, now observe this program. Observe this program. We have an interface, right? And we use the keyword called interface. Okay, programmatically we create an interface by using the keyword called interface. Okay, and it is not a class. Again, I'm repeating, this is not a class. This is an interface, right? So what type of methods we can write in an interface, right? What are the things that you can perform on the mouse? You can perform only action. Only action means what? Abstract method, right? Abstract, void. What are the things that you can perform on the mouse? You can click on this, right? It's giving an error. Can anyone tell me why error? Just think about it. Why error? For 2 to 3 seconds, think why error? Because this method is abstract and I've written a logic for the body, right? I should not write it. I should end this with semicolon. Observe, correct? Similarly, I'm going to define, or sorry, I'm going to declare another method called double click, okay? All right. Similarly, I'm going to have one more method called right click. These are all my abstract method. Even if you try to write a logic for this method, observe here, it's giving an error. Why error? Take the mouse pointer on this error. Observe, abstract methods do not specify a body, means it is automatically considering this method as abstract. So hence, even if you don't mention it as abstract, interface methods are automatically abstract. Hence, you cannot give the body to this. Are you clear? Now observe. It's a little tricky, just observe. Here I used a keyword called abstract, but in the fourth line, I've not used any keyword called abstract. It means to say these two are abstract methods. What about this one? Remember, automatically all the methods in an interface are public and abstract. It is not just abstract, it is public and abstract. Okay, this method is public and abstract, public and abstract, public and abstract. All right, but we have seen in previous video that when I was explaining you access specifier chapter, right, public, private, protected, and default, at that time I had explained that this method, when I don't mention it as public, you remember? Remember, when I don't mention it as public, it is automatically default. This is what I had explained you long back. But that rule is not applicable for interface. When you don't mention anything, only this is applicable only for interface, okay, not for others, right? Whenever I declare a method in an interface, then those methods are automatically public and abstract. Public and abstract. Don't forget this, okay? Automatically, it is not default now. Don't ask me questions, sir. When I don't mention anything, it is called default. Yes, for regular case, but in interface, it is special. It's automatically public and abstract. Okay, so what is the conclusion? We declare an interface. We create an interface by using the keyword called interface, and all the methods in an interface are automatically public and abstract. And we cannot write any constructor in an interface. If we write, this is not possible, right? Interface cannot have constructors. All right, interface, observe here, interface cannot have constructors. Why interface cannot have constructors? But it was there in abstract class. Why it is not present here? Because we cannot have instance variables. We cannot have instance variables or states, right? We cannot have instance variables or states in an interface, so we cannot have constructor. So what is the whole purpose of writing the constructor? The whole purpose of writing the constructor is to initialize, correct? No, initialize. But now the funda is that since we cannot have instance variables here, there is no question of initialization. That's why we cannot have the constructor. Are you clear? Third thing, very important, we cannot create an object of interface. This is also extremely important. Like abstract class, we cannot create an object of interface, right? If you try to create, you beautifully get an error. Okay, so remember, you cannot create an object of interface. So so somewhere, if I try to create an object like this, what was the name of that interface? Mouse and equal to new mouse, right? This is 100% wrong. You're going to get the compilation error. This is never possible. Okay, you cannot create an object of interface. Interface cannot have instance variable. Interface cannot even have constructors also. This is how we create an interface. So now where are we supposed to create an where are we supposed to override these methods? Someone has asked a question. Only abstract methods. Yes. Okay, so this, as in the diagram I had explained, interface has only abstract methods, right? These abstract methods must be overridden. Observe, the logic must be written in the subclass, and that subclass must be the service. So what is the service of this particular mouse? Mouse is an interface which has the service called computer or the CPU. So now I'm going to write a class. I'm going to write a class called CPU. I'm going to write a class called CPU. All right. In the CPU class, I'm supposed to connect. Observe, I'm supposed to connect here. This is where I have connected. All right. This is where I have connected. What I have connected here? I have connected the CPU and the mouse. Correct? No? How do you connect it? Right? This connection is done by using the keyword called implements. The meaning of implements is you are giving an implementation, right? Implement is a keyword. What is the meaning of this implements? Just observe here. I have a keyword called implements. When I say implements, this has got the meaning, okay? When you say implements, you are somewhere giving the implementation. You are giving what? You are giving implementation. What do you mean by implementation? Implementation means logic or the body. Logic or body, right? You are somewhere giving the logic or body. Implementation means what? It is nothing but the logic or body which makes, it is a mechanism, it's a mechanism or the body or the logic which makes the system to work, right? So mouse has only an option of clicking, but where is the option to make it to work, right? That is present in CPU. Now CPU implements mouse. CPU implements mouse. Are you clear now? So this is called as the subclass of this interface. So interface is the one which works like a super. This works like sub. Okay, now this is called the subclass of, please observe, this is considered as the subclass of interface. So if someone asks, how do you inherit this? Inherit by using the keyword called implements. I'll just open this. So here is the word implements, means inherit, right? So it means to say this is going to be the subclass. This is going to be the subclass which is inheriting an interface. So basically, your interface is working like interface is working like a super. This is going to be your interface, and this is going to be your subclass. What is the name of the interface? Mouse, right? And CPU is the subclass. This subclass of an interface is technically, a better word for this is implementation class. Never forget this. It's technically called as what? Implementation class. From now onwards, I often use this word called implementation class. So you should remember that. If someone suddenly asks you what is the meaning of implementation class, you must answer the subclass of an interface is called implementation class. I'll repeat, the subclass of an interface is technically called as implementation class. All right, so a subclass called CPU, how does it inherit an interface? By using the keyword called implements. And in the class diagram, in the class diagram, we represent this by using dotted line. We represent it by using dotted line. So dotted line indicates implements. Dotted line indicates implements. All right, so this is going to be your interface. This is going to be your interface, and this is going to be your subclass. Okay, this is called subclass. Subclass is also called as what? Implementation class. So this is the subclass and this is the super interface. And how interface is inherited by the subclass? By using the keyword called implements. So that's one funda here. Okay. Next, it's giving an error if you observe. Like abstract class, here in the abstract class, we have seen that when a subclass extends an abstract class, we have to override abstract methods. Correct? I'll repeat, in case of abstract class, we have seen in the previous topic that whenever we write a subclass which extends an abstract class, I'll repeat, whenever we write a subclass which extends an abstract class, then we have to override abstract methods in the subclass. Correct? In the same way, here also, whenever I write a subclass which implements an interface, we have to override all the abstract methods. Okay, how many abstract methods are there? 3 abstract methods are there. Hence, we need to override all the 3 abstract methods here. All right, observe now, I have overridden all the methods. Okay, so mouse is an interface which has got only abstract methods. This is a service, nothing but a subclass which has got implementation. Right, now observe this diagram. This is what I had explained now. You have only abstract methods in an interface, right? You have only abstract methods in an interface and they are overridden in the subclasses. This is the logic. Logic is nothing but implementation. Implementation is nothing but mechanism. So here is the mechanism which makes the computer to work. What happens when you click on a mouse? Just observe. I'm going to click. What happens? A resource called notepad gets selected. I clicked on here. Click is an action. What is the reaction? That this folder is getting highlighted or gets selected. I click, which is an action. What is the reaction? This is getting selected or highlighted. This is getting selected, right? That is a reaction. So when you click, what is the reaction? The resource gets highlighted. The resource gets highlighted, all right? Similarly, when you double click on this mouse, what happens? Observe, double click. Double clicking is an action that I perform. Try to visualize this, guys. Where do you double click? Do you double click directly on this notepad or do you double click on the mouse? Visualize, you are performing an action called double click on the mouse. What is the reaction now? The notepad plus plus, right? The notepad plus plus is going to open, right? Similarly, all right, if let's say you have a music player, you double click on the music player, that is an action. It's going to play the music, that is a reaction. Clear? So here is the reaction. What is that reaction? The resource gets opened. The resource gets opened. Similarly, when you right click, what is the reaction? The reaction is that display options. It display all the options. When I right click, observe, right clicking is happening. That's an action which is happening on my mouse. It is showing me all these reactions. That is nothing but, right, the implementation. So this is called an implementation, implementation, implementation. So these are all called actions. These are all called reactions. Are you clear? This is the basics. Even if you don't override one method, it starts giving you an error. So you have to override all the methods. If you don't override, it gives an option. It gives you an error. The only option that you have is you have to make the class as abstract, because in this class called CPU, which is an abstract class, has 2 concrete methods but 1 abstract method. Which is that abstract method? Right click, right? These 3 abstract methods are inherited to the subclass where you have concretized only 2. Still 1 method is abstract. Are you clear? Now you don't want to do that, then you have to override it. Are you clear? You cannot create an object of interface. You can use the interface to access this particular subclass. What is the meaning of it? Let's say the computer user, right, has a CPU, Please understand, this is a CPU object. This is a CPU object. How you are going to operate the CPU? By using, okay, now observe, I cannot create an object of interface. If I try to create an object of interface, I get an error. Observe, it's giving an error. You cannot instantiate. Instantiate means what? Creating an instance. Creating an instance means creating an object. You cannot create an object of this interface. But a super interface, this is a super interface, can be used to create an object of the subclass. It means to say the reference is from super interface, the object is from subclass, and we know this concept as what? Upcasting. It's called upcasting. It means to say we cannot create an object of interface, but interface can be used to refer. I'm just only creating a reference. It can be used to refer a subclass object. So this is a subclass object. This is the super interface reference, nothing but upcasting, right? Also remember, interface can also be considered as a custom or non-primitive data type. Okay, it can be considered as custom or non-primitive data type, like your class and abstract class. So class is a data type, abstract class is also a data type, and even interface is also a data type. So all are considered as the data type. Are you clear now? Now, next thing, since it is an interface, it is a good practice. Now observe, no errors in your program, no errors. It is just a good practice that you should start the name with I. It is a good practice. Again, I'm telling you, don't ask me a silly question. Is it a rule? No, it's not a rule. It's only a good practice. All right, it's a good practice that interface name should start with I. So there are two good practices that we follow. Okay, some of the people write this interface in this way, right? They write like this: I mouse. This is one good practice, or you can also say mouse INF. Either it should start with I or it should end with INF. These are all the two good practices. Okay, but it is not a rule. It's only a good practice, not a rule. It's not a rule. Okay, and I also taught you that the subclass of an interface is called implementation class. So that's why this class, again, it's a good practice that it should end with IMPL. It should end with IMPL. Anything with ends with, this is the project standards. Okay, this is the coding standard. Anything that ends with IMPL, blindly think that it is the subclass of interface. Subclass of an interface is also called implementation class, which has got an implementation, nothing but a mechanism. That's why it is called as what? Implementation class or subclass. Hence, I have ended this name with IMPL. Since it is an interface, I started this with I. So how are we going to represent in the class diagram? We have something called class diagram. How do we represent it? The way to represent it is, observe here. So, okay, I write like this. This is going to be my interface. This is going to be my subclass, okay? What is the name of this interface? iMouse. And what is the name of this? CPU EMPL, CPU implementation. So remember, very important here, we use the stereotype, right? A stereotype called interface. In abstract class also, I have taught you, we use a stereotype called abstract, right? We use a stereotype called abstract. Similarly, now we use a stereotype called interface. All right. So now also implements. Implements is represented by a dotted line. Though don't get confused. If it is a solid line, it indicates extends. If it is a dotted line, then it implements what? It indicates implements. So this is parent and this is going to be child. All right. Now what am I going to do? I give the reference of this interface called iMouse a reference. I'm giving only a reference, but I'm going to create an object of this subclass. New CPU IMPL. So the object is from subclass here. So object is from object of subclass, right? This is a reference of super. So super reference subclass. This concept is, right? Technically, this concept is called as what? Upcasting. Right now, I have only explained you what is interface, what does it contain, how to write the subclass, how to override, what is upcasting. But you don't know anything about the uses of it. You basically don't even know where it is going to be useful. Correct? You don't know. If someone asks why it is required, you don't know. I'm not explaining this, okay? Are you clear? So do you have any questions on this apart from the uses? Right? If you have any questions related to what are the users of this interface, don't ask that. Apart from that, if you have any questions.
This conference will now be recorded.
So Anu has asked me a question that, sir, from 1.8 version of Java, concrete methods can be defined in the interface. Observe, in my case, I'm using, if you just go to Eclipse, compiler version. If I look into the compiler version, what is the version that I'm pointing to? 1.8. Now observe, from 1.8, it is possible to, listen to me carefully, it is possible to define concrete methods. All right, just an example. Observe, I'm writing a logic, but it started giving me an error here. So it should be either static. Now it works. So this is called a static concrete method, okay? This is called a static concrete method. It is possible from 1.8. Similar to this, I can write one more. I'm going to write one more method called M2, but I'm not going to make it as static. I'm going to make it as default. Okay, so this is called a static concrete method. This is called a default concrete method. Suddenly, you may get a question, what is the use of these two? In what situations we use them? Which again, I'm going to teach you in tomorrow's class. Okay, Smita asked me a question, in what kind of concrete methods can be defined in an interface from 1.8? Okay, so my answer is that static concrete methods or default concrete methods can be defined. I'm using the word defined, means it should have definition means logic. Observe, I'm writing a logic here. This is going to be the logic. Okay, it is possible that from JDK 1.8 we can define either static concrete method or the default concrete method. What is the use, in what situations we are going to implement it, I will teach you in tomorrow's class, not in today's class. Okay, I think I have answered Smita's question. No, Anu is again asking the question, sir, do I need to override the concrete method? Please observe, Smita, sorry, Anu, here M1 is going to be a static method and you cannot override a static method. Remember, you cannot override a static method, but you can override this default method, okay? The second method, which is default, you can override that in the subclass, but you cannot override this static method. Rajiv is asking one more question. Is it compulsory to provide implementation to every abstract method which is present in the parent class or in child class? Yes, Rajiv, compulsory. Rajiv, yes, yes. Now I have three abstract methods. It is compulsory to override three abstract method in the subclass. Let's say if you don't override any one method, then the subclass also becomes abstract. So you should declare the subclass as abstract. Very important. Okay, hence you in this case you cannot again create an object of this subclass also. That is the reason you have to override all the abstract methods, all the inherited abstract methods. All right, Vijay, yes, we can define data member, but that should be public and final and static. We will talk in tomorrow's session, Vijay. This is a very big concept, guys. This interface is a very big concept. Like, you have to fundamentally understand what is interface, how to create, how to override that in the subclass. What is the purpose of this interface? Can it have constructor? Can it have data member? Right? There is something called types of interface. Okay, we have three different types of interface, and where exactly it is going to be useful? What is the meaning of coding contract? What is the meaning of rules repository? Right? So how multiple inheritance can be achieved here in case of interface? What makes to achieve the multiple inheritance? So it's a very, very big concept according to me, which cannot be taught in 1 hour or 2 hours. So basically, according to me, interface alone will go for at least 8 to 10 hours, according to me, right? No, Bhavani Prasad is asking a good question. Does it inherit object class? No. We are going to discuss about the inheritance and the types of inheritance with respect to this interface in our next video. Okay, in our next video, we're going to discuss. So just what we are supposed to do is you just have to give me some time, like maybe around next another at least 6 hours you should give me. I'm going to beautifully teach you what is this interface in and out. Okay. Hmm? So for now, we are going to end this session for right now. So we will meet tomorrow. I'll explain you some more things about interface. Okay. Thank you very much.